Okay, so we will talk about tangent and cotangent first, and then we will see the graph of secant and cosecant, and we will also practice the graph of translation of secant and cosecant. All right, let's see if okay. Let me open my okay, I guess 6.4. Okay. Okay, let's talk about first the periodic properties of tangent cotangent. The both functions, tangent and cotangent, they have period pi. So that means we have tangent of x plus pi is the same as tangent x, and cotangent of x plus pi is going to be the same as cotangent x. All right, that's for these two functions. And for all other functions, cosine, sine, secant, and cosecant, they have a period 2 pi, everybody. All right? All right. Now let's see how we sketch the tangent graph. The first thing we should need to remember that tangent is undefined for the odd multiples of pi over 2. So, for example, tangent of pi over 2 is undefined because it is, definition is y over x, so x will be 0 on the terminal site of pi over 2. Remember, we just covered these things before. And tangent of negative pi over 2, which is the same as a positive 3 pi over 2, right? Positive 3 pi over 2 or negative pi over 2. They are coterminal, as you remember. So these two are undefined because of the tangent definition. So the graph of tangent close to these points, we need to be extra careful because it will take a larger and larger value as we get close to pi over 2 and the negative pi over 2, then it will be opposite, and negative of the large value will be a negative number. And so let's see the image and a couple of calculations. Again, as it is undefined for negative pi over 2 and positive pi over 2, so we are drawing vertical lines, which we call it vertical asymptote. And to have some idea about how to sketch the tangent graph, we can choose a couple of points and to see if it is, increasing or decreasing. Let's check point at the origin. If x is 0, for example, tangent will be 0, right? Tangent of 0 is 0. And when I check another point, for example, pi over 4, well, tangent of pi over 4 is 1. Now it just start increasing. How about, let's choose pi over 3. Well, pi over 3 is greater than pi over 4, of course, but less than pi over 2. It is somewhere here, right? It is pi over 3. All right. Do we remember what was tangent of pi over 3, Shabab?
Root 3, I think.
3.
Yes. Tangent of pi over 3 is root 3. So y is equal to root 3, right? Root 3 is greater than 1, huh? Somewhere here. So if x is pi over 3, and looks like to make it a little bit accurate looking, Shabab. So let me just. So here is the root 3. For example, it is greater than 1. So here is the pi over 3 here, Shabab. All right. So as you get closer to pi over 2, let's see approximately how much is pi over 2, everybody. If you divide the pi by 2, right? Let's divide pi by 2. Pi divided by 2 will be close to 1.57, right? Okay. So if x is equal to 1.56, which is quite close to pi over 2, but little bit less than pi over 2, everybody. Okay. Then what happens to tangent of 1.56? Tangent of 1.56 radian.
Undefined.
No, it is not undefined. Is exactly tangent pi over 2. Tangent pi over 2 is undefined, but this number is a little bit less than pi over 2, and it is not undefined. Let me see what happens to tangent of this number. I'm just using my calculator, of course. 1.56 radian. What is tangent? Okay. 1.56 radian tangent. Almost 93. So it is close to 92.6. You see that? So if you choose a closer number to pi over 2, the tangent just flies up, So y is equal to?
Doctor?
Yes.
You have to put radian, right, in the calculator.
Yeah, these numbers are radian, Shiva.
Yeah.
Right? These are pi over 4, pi over 2. These are radian calculations, yes. So tangent of 1.56 is close to 93. So it just goes up very fast. And of course, as soon as you touch the pi over 2, then tangent is undefined, of course. That's why we put the asymptote here. And similarly, if you come closer to negative pi over 2 from this side, all right, then you will get the same value, but the negative of the same value. If you try negative 1.56, which is closer to negative pi over 2 on the right side, so the y value will be the negative 92.6. So it is just going down to negative infinity. All right. So that is the typical picture of tangent. It's a one period image. And as you see, the distance between the two asymptotes, everybody, distance between the two asymptotes is one period, which is
Pi.
Pi. Exactly, which is pi. And if somebody likes to sketch more, images of tangent, you need to just, copy this picture and then paste it to the next between two asymptotes. For example, if you like to see the next asymptote after pi over 2, you just need to add the pi. So pi over 2 plus pi will give you 3 pi over 2, which is another period, another asymptote. So you can just copy the exactly same picture.
Doctor.
Yeah.
What happens when we put pi over 2 with tan? Is it 0?
Pi over 2?
Yeah, tan pi over 2. It's 0, right?
Undefined, Shiva.
Undefined. Oh, okay.
Undefined. Yes, exactly. Undefined. Okay. Here is the, three more images. 3 images of tangent. So what you should notice that to find the next asymptote, we just add pi to the asymptote, or to find the asymptote on the left side, we subtract. We subtract the pi. So we keep subtracting pi to go to left side, and keep adding pi to go to right side. And also just notice what's happening to what in the x-intercept. You see the x-intercept is 0 here, right? Origin. What is next x-intercept? Pi.
Pi.
You see? So what is the distance here from 0 to pi? Again,
Pi.
one period, pi. You see? The distance is pi. So it looks like I can find the x-intercept also by adding the period. So after the pi, what is the next x-intercept, Shabab?
2 pi.
2 pi. And then 3 pi. And then 4 pi, 5 pi. So now we can see that the x-intercept of tangent is n pi. Okay? 0, 1 pi, 2 pi, 3 pi, 4 pi, and also negatives, of course. All right. Sure. Let's see what's happening with cotangent. Well, in the cotangent, the 0 is, the one asymptote. Let me just put 0 here for you. And also pi is undefined. And remember, 0 and pi, it was x-intercept for tangent, remember? Let's go back to tangent again, you see? 0 and pi, they are x-intercept for tangent. But now it is asymptote for the cotangent. Why is like that, Shabab?
Because when you flip, it will be a number over 0. Yeah, undefined.
Aywa, perfect. Because cotangent is 1 over tangent. You see?
Doctor?
And yes.
So can we just say it moves pi over 2 to the right and flips?
It's a kind of, right? It is multiplied. It's first multiplied by negative. If you multiply the tangent with negative, so it flips. So increasing graph becomes decreasing, right?
Yes.
And also the move to the right side.
By pi over 2.
Yeah. It's nice, right?
Okay. Thank you.
Yeah. Very good. So just to show you some calculations, you know, cotangent of pi over 4 is 1. Cotangent of pi over 2 is 0, you see, x-intercept. And cotangent of 3 pi over 4, which is negative 1, of course, 3 pi over 4 in the in the second quadrant. All right, again, when you come closer to 0, Shabab, when you come closer to 0, then cotangent will get large values, you know. Cotangent will get large values. And as you get closer and closer to 0, so cotangent will not stop and goes infinite. And similarly, if you come closer to pi, you know, if you get closer to pi like this, then cotangent value will get, you know, negatives and smaller numbers. So it just goes down to negative infinite. That is what happens if you get closer to asymptote, Shabab. So that is the image. Yes.
So if we use the calculator and put tan or cotan and put numbers like 0.0001,
Yeah.
will the answer be high number?
Yeah, مثلا let's see what happens. Cotangent of 0.001, right? It's very close to 0. Why not? 0.00 another 01. You see? Now I'm trying 0.0001, Shabab. And let's see what happens to cotangent. All right. In my calculator, we don't have directly cotangent. I will take the tangent first and then flip it. Let me find the tangent of this number is, okay, and then let me flip it. Oh my God, it is 10,000. It is 10,000. 9,099.99. Interesting. So cotangent. Yes.
It needs to be in radians, right?
Yes, Shabab. These are radian numbers. Yes, very good. 0.001 will be close to almost 10,000. 10,000, Shabab. You see how cotangent flies off, you know? Right?
Infinity.
Yes, so that means if you just get closer to 0, then a y value will not stop and it will go to infinite. Yes. This is the basic definition of asymptote, everybody. When you get closer and closer to vertical asymptotes, then the functions either will go up to infinite or will go down to negative infinite. Okay. So that is the Shabab cotangent image. So we should just remember this image so that we are going to use it to sketch the, you know, the other questions. Okay. And here is the couple of more images for cotangent. So let's look at how is the the asymptotes of cotangent, Shabab. You see, we have 0 here. We have pi is asymptote. 2 pi is asymptote. Negative pi is asymptote. So looks like the asymptote for the cotangent is n pi, as it is, given n pi.
Doctor?
Yes.
So the x-intercept for the tan is the same as the vertical asymptote for the cotan, and vice versa.
Yes, vice versa. Yes, exactly.
Okay.
And if you look at the x-intercept of the cotangent, right? Pi over 2, 3 pi over 2, and also negative pi over 2, right? So it is an odd multiples of pi over 2, you see? 1 pi over 2, 3 pi over 2, next will be 5 pi over 2. So if you can remember like this, you see, odd multiple of pi over 2. Okay, so here is the time for cosecant. Well, it is as simple as a graph of sine function, because cosecant is 1 over sine. So basically, we start sketching the sine graph first for one period. It is one period, the 2 pi, as we remember. And because the definition cosecant is 1 over sine, if sine gets 0, right, then 1 over sine will be undefined, huh, Shabab? Okay. When is sine 0, Shabab? Well, x-intercept, right? The x-intercept, that means sine is 0. So 0 is the one x-intercept. Another x-intercept is pi. So another x-intercept is 2 pi. So that means at these numbers, at these points, cosecant will be undefined, because it is 1 over sine. A sine is 0, so cosecant is undefined. So I sketch vertical asymptotes at the x-intercepts. And then how does the graph look, Shabab? It looks like a parabola, right? One parabola is facing up, another parabola is facing down. You see? They meet, they are touching each other at the top point of sine, and at the vertex, a kind of vertex of the parabola, right? It is touching to the sine graph. And also at the other one is touching the sine graph, at the lowest point, and it is the highest point for the, the parabola which is facing down. So we have two parabolas here for this cosecant graph. So if you know how to sketch sine graph, so the cosecant is easy to remember, I guess. And well, maybe we can try to remember some more values. You see, if x is pi over 2, what was the sine pi over 2, Shabab? 1, right? And also cosecant pi over 2 will be 1, because 1 over sine, 1 over 1 is 1. So they are both 1 here. That's why they are touching each other, everybody. Let's try another number. Look, let's try pi over 4, right here. Pi over 4. And what is sine pi over 4? Do you guys remember?
root 2 over 2.
Root 2 over 2.
Root 2 over 2, yani 1 over root 2. Let's see. It is 1 over root 2. But how about cosecant?
It will be root 2.
Root
Root
2.
2.
You
Yeah.
see? Because you need to flip, right? You need to flip. If you go to cosecant شباب, it will be root 2. So cosecant gets, you know, larger than here. Larger than sine. Sine is 1 over root 2, but cosecant is root 2. Well, how about pi over 6, Shabab? Maybe you remember pi over 6 is even less than pi over 4. Pi over 6 here, let's see. If x is pi over 6, what is cosecant
Half.
pi over 6?
And
2.
cosecant is
The
2.
secant will be 2.
You see, sine is half, but secant is 2. You see, sine is getting close to 0, but secant is going up. So secant will be 2 here. Sure, Shabab? So as you get closer and closer to 0, sine will be close to 0, right? If you get closer to 0 radian, then sine is going to get 0 value, right? But cosecant will get much larger value.
Yeah.
Yes. That's why, you know, parabola is just flying up, Shabab. Okay. Well, everybody, this is as simple as sketching sine graph. And just remember, these two parabola, one is up, another is facing down.
Doctor,
Yes.
is there a period length here?
Yeah, period is 2 pi.
Yes.
Period is 2 pi. So in the between two asymptote here, it is pi, yani half, you know, between two asymptote. It is not one period, it is half period. Because this is not tangent cotangent, right?
So we consider it. We consider the two parabolas as one period.
Yes, two parabola is gonna give you one period picture. Yes, exactly.
Okay.
Very good. All right. And here is the secant image, Shabab. Well, we just need to remember cosine image, right? So the one period of cosine image from 0 to 2 pi, after we sketch the cosine image, we just draw a vertical lines at the x-intercept. Because that's going to be undefined numbers for the secant.
So this one is for everyone, right, Doctor? The x-intercept is asymptote.
Yeah, x-intercept is that means it is asymptote for secant and also asymptote for cosecant. Sure. Yeah.
Yes.
In the cosine, one x-intercept is pi over 2 here, and another x-intercept is 3 pi over 2. So that means these are two asymptotes between 0 and 2 pi. Yani in one period here, we have two asymptotes for secant. And if somebody likes to calculate a little bit more, Shabab, let me just, you know, prolong the x line. And if you like to continue cosine image a little bit more like this, then do you think we can find these numbers here?
5 pi over 2.
So this number is 5 pi over 2, right? 5 pi over 2. So I can sketch another asymptote here, you see?
And it becomes a parabola, right?
And parabola, yes, parabola will complete. شوف شباب. Parabola will complete just like, you know, before. And also you like to go to left side little bit. If you go to left side, شباب. And this point is
minus pi over 2.
exactly. So it is negative pi over 2. And I can sketch another vertical line here. Oops, my vertical line is not good looking. Sorry for that. And you can now complete the cosine, I mean the secant parabola, you know, like this, Shabab. All right. So again, parabola facing up and down. Another parabola up, one parabola down, parabola up, parabola down. Depends on if the cosine graph is above the x-axis, that means parabola is facing up. If the cosine graph is below the x-axis, that means the secant parabola will face down. Understand? Just like in the sine graph. If sine is up, then cosecant will be parabola, which is facing up. All right. So by the practice, of course, we will see, you know, couple of more the images for cosecant here, and also a secant. If you just continue sketching sine and cosine, you know, a little bit more than the one period, so you can see the images of a secant and cosecant, you know, more than one period. So as you see, Shabab, it's just a parabola facing up and down, up and down. All right. For the transformations, Shabab, if you have a tangent or cotangent of kx, then the new period will be pi divided by k. All right. For example, if you have tangent of 2x or cotangent of 2x, period will be pi over 2. All right. And to sketch the graph, it was originally between 0 and pi for cotangent. Remember, between 0 and pi. But now for the kx, if you find the x, it will be between 0 and pi over k for the cotangent. So it's going to be the one period for cotangent from 0 to pi over k. All right. So for tangent, Shabab, it's going to be between negative pi over 2k and positive pi over 2k. So the two asymptotes are kind of getting closer. Yani the graph is getting, you know, shrunk, right? Right? And depends on the value of k, the graph can, you know, shrink or stretch. All right. If k is 2, for example, Shabab, if you have tangent of 2x or cotangent of 2x, what happens to graph? Do they stretch or do they shrink?
Shrink.
They shrink, yes, they shrink. And let me write it here for you to remember. We sketch the graph of tangent x between negative pi over 2 and positive pi over 2, right? These are asymptotes. But if you like to sketch tangent of 2x, Shabab, so what do? We divide by 2. Exactly. if you divide by 2, Shabab, it will be negative pi over 4 is one asymptote, and another asymptote is positive pi over 4. Just divide it by 2. So you will sketch the, this basic increasing tangent image between the negative pi over 4 and positive pi over 4. All right. And if you like to sketch tangent of, for example, tangent of half x, then what happens? If you divide by half, divide
from
by
minus
half
pi
is,
to pi.
Half, yeah.
Exactly. It will be between minus pi and positive pi. You see now it is stretched, right, Shabab? Right and left. Stretched. Eyvah. And similarly for the cotangent, Shabab. Similar operations, we do to cotangent. Okay. Here is again, suppose you have tangent of 2x. So as I explained, your graph will be between the negative pi over 4 and positive pi over 4. All right. And then we're going to see the, shift of this graph. If you switch x with x minus pi over 4, you see, from the x, we switch to x minus pi over 4. What happens to graph? All right. Graph goes to right, pi over 4 units. All right. Let's see. So here is the, again, image that we were talking about. Negative pi over 4 and positive pi over 4. These are the new asymptotes. And then we sketch the increasing, tangent image above. We have the 0 is x-intercept again. And remember, it was here pi over 4 before, right? Tangent pi over 4 is 1, of course. But now pi over 4 became pi over 8. Because we divide by 2, huh? Yes, if x is pi over 8, then 2x will be pi over 4, right? If x is pi over 8, then 2x will be pi over 4. Again, tangent pi over 4 will be 1, of course.
Doctor?
Yes.
If it was just tan x, how different would it be? How would it change if it was just tan x, not 2x?
Yeah, just go back to the 10x image, Shabab. You will see that. So this will be negative pi over 2. This is pi over 2, and this is pi over 4.
So,
Yes.
is there any amplitude for those functions or not? Like
No.
sine and sine?
Yes, and the amplitude is for only sine and cosine, Shabab. It is only for sine and cosine, not for tangent, cotangent, secant, and cosecant. Okay, now if you like to sketch more the images, then you just need to find the next asymptote, Shabab. We have pi over 4. What is the next asymptote? Well, I need to add what, Shabab? What is this distance, Shabab, here?
Pi.
The pi over 2.
Pi over 2.
Yeah, pi over 2.
Yani one period, right? A period is pi over 2, huh, Shabab? So, okay, pi over 4 plus pi over 2 will be 3 pi over 4, huh, Shabab? So you get another asymptote. And just copy the same image between these two asymptotes. And notice that, Shabab, you can do the same thing for x-intercept. So first x-intercept is origin 0. What is next? You see pi over 2. Again, one period, you see? 0 plus pi over 2 is pi over 2. So you get another x-intercept. And you like to go to left side, then keep subtracting. This is how you sketch, more copies of tangent and also cotangent. Now, Let's go to next slide and see what is happening for the shift. Now I give you the image of tangent 2x, also tangent of 2 times x minus pi over 4. That means a shifting of tangent 2x pi over 4 units to right. So how do we shift the graph right, everybody? Basically, we are adding pi over 4 to every number in the x-axis, so that you will get the new asymptotes and new x-intercepts. All right? Let's focus on the red image to clearly understand what's happening. You see, Shabab, we have negative pi over 4 before the shift. Now let me shift it now. Negative pi over 4 plus pi over 4. What happens? It becomes 0. Now 0 is the asymptote, you see? And another one before the shift, pi over 4, right? And now I have to shift it to right. Yani, I have to add the pi over 4. Pi over 4 plus pi over 4 will be pi over 2.
Pi over 2.
You see how the red image shifted, Shabab? And also x-intercept. What was the x-intercept here? 0. A 0 plus pi over 4. So now you have x-intercept pi over 4.
Pi over 4.
Eva. So you have to do the same thing for every number, you know, of on the tangent of 2x to get the image of the shifted graph. So it's just a matter of changing the numbers, Shabab. Just changing the numbers on the graph of tangent 2x. Just erase it and change it so that you will get the shifted image. All right. So we have also 2 times cotangent 3x minus pi over 4. In this case, Shabab, if you like to find the phase shift, you can either, take the 3 as a common factor, as it is seen here, and then you will see the x minus pi over 12. So to see the phase shift. Or it is the phase shift, shifting of cotangent 3x pi over 12 units to the right.
Doctor?
Yeah.
I have a question.
Yeah.
In math 001, we took that the horizontal shrinking must be with the x. It's like f of a x. So why when we have to make the graph of cotan and tan or any trigonometric function, we must take the 3 as common factor?
Yeah, we are taking the 3 as a common factor to see the, changes of the x. So now imagine cosine of cotangent of 3x and cotangent of 3 times x minus pi over 12. You see what is happening here? We see the replacement of x by x minus pi over 12. To see the replacement of x, how do we replace x? You see? Or it is a little bit maybe more clear for you. Please solve this equation for x. Just make 3x minus pi over 4 equals 0, and then solve for x, everybody. So you will get x equals 12. That means it is a shift is pi over 12 units to right.
So
Yes.
we take 3 common factor to see the phase shift.
Yes. Yes.
Okay, thank you.
Very good. Very good. And now Remember the cotangent for cotangent 3x, the new asymptotes are 0 and pi over 3, right? Because cotangent x, what was the asymptotes? One is 0, another is pi, right, Shabab? But when you have 3x, so I need to divide by 3. 0 divided by 3 is 0. Pi divided by 3 is pi over 3. These are the asymptote for cotangent 3x. And if somebody has a question about this number 2, it has nothing to do with asymptotes or, shift. It has, vertical shrinking or stretching, right, Shabab? So that's why we are not touching this number 2. So if somebody is, wondering what's happening to 2, we have no problem with 2. Now, this is for cotangent 3x between 0 and pi over 3. Well, how about after the shift? Right?
We add pi over 12 to each one.
Yes, because I'm talking about now 2 times the cotangent 3 times x minus pi over 12. So that means I need to add pi over 12 to the numbers before the shift. So 0 plus pi over 12 is pi over 12, and pi over 3 plus pi over 12 is 5 pi over 12. So these are the new asymptotes for cotangent, shifted asymptotes. So I can sketch the cotangent graph between pi over 12 and 5 pi over 12, Shiva. So if you like, I can just sketch it here for you. All right, where is 5 pi over 12? Of course, it is very close to 0 here, pi over 12, right, Shiva? And 5 pi over 12 is here. All right. And let me see a different color. So cotangent was decreasing graph, right, Shiba? So I will sketch a decreasing graph if I can. I guess, yes, I did. You see, so it is pi over 12 here and 5 pi over 12 here. And of course, if somebody wants to find the x-intercept, it is also easy because it is just a middle of the asymptotes. You see, Shabab? So if you know how to find the middle of two numbers, add and divide by 2.
Subtract by 2.
Divide by 2.
Divide by 2, yeah.
Ava. So you can find the x-intercept, Shabab. So this much simple. So here is the better clear image for cotangent. So the pi over 12 and 5 pi over 12, and looks like in the middle the x-intercept is pi over 4, and for the next asymptote, Shabab, how can I find the next asymptote? So
we add
pi over
what?
3.
Over 3.
Just the period pi over 3. So 5 pi over 12 plus pi over 3 is 3 pi over 4, Shabab. If you like to sketch more images, go to right, add pi over 3. Go to left, subtract pi over 3. You see, pi over 12 minus pi over 3, Shabab. Pi over 12 minus pi over 3 will give you negative pi over 4. Yes. And similar for the x-intercept. If you know pi over 4, then you can find the next x-intercept, Shabab, 7 pi over 12. Just add the pi over 3. Pi over 4 plus pi over 3 is 7 pi over 12. All right. Is that confusing or clear, everybody?
Yes,
That's
clear.
clear.
Doctor.
Yeah. So I'm sure it is okay, inshallah. But looks like we finished the time, Shabab.
Okay, fine.
Time is just flying so fast. Okay, let me just stop here. And so, inshallah, we'll continue from this part.
Doctor,
Yes.
do you have office hour before 8?
Yeah, you guys have a quiz, so I will, inshallah, have extra time. Maybe I will try to get online at 6:30, and then we will have, long time until quiz, inshallah.
Okay, thank you, Doctor.
Learn.
So 6:30 I check?
Yes, please.
Okay, thank you, Doctor.
Doctor,
Thank you,
the
Doctor.
quiz 8 p.m., right?
8 p.m. Yes, Shabab. 8 p.m.
Okay, thank you, Doctor.
Ahlan. Good luck, inshallah.
Thank you, Doctor, and have a nice weekend.
Yes, thank you,
You
Doctor.
too. You too.
Doctor, 5.3 is not solved in the OneNote. Can you check it?
5.3.
Yes, it's not solved in the OneNote. Can you check it, please?
I will look at it, inshallah. And maybe is the lecture video with you, inshallah? You can look at again, maybe.
Okay.
I will see, inshallah.
Okay. Thank you.
Ahlan.